This is Engine Repair 2 Test 4, and that's from your textbook, chapters 13 and 14. Coolant is water and what? It's made of water and what else?
Ethylene glycol.
Ethylene glycol. That's right. And ethylene glycol is peculiar stuff. It's kind of poisonous. However, if occasionally you'll see it, you'll see something like polyethylene glycol that they put in different stuff that you can buy at the store. Like one time I bought some what you'd call, you know what gripe water is for kids with hiccups? This stuff that you buy at the store. It's clear stuff in a little bottle, and if the kid's got hiccups, you're supposed to be able to give him a spoonful of it, and it makes the hiccups go away.
Where was that when I was little?
Yeah, and I had some hiccups. Well, you can get it at the drugstore. And I was having hiccups one time that I wanted to get rid of. You know, that they lasted about 3 or 4 days. But anyway, I took some of this gripe water stuff, and I went and bought it. It was like $11 for a little bottle of it. And as soon as I put that spoonful of stuff in my mouth, I said, that tastes like I just drank a spoonful of antifreeze. And I flipped it around, I looked on the back, and it's like it was polyethylene glycol or something. You know, it's really weird. But you don't go there though, because it's not good for your kidneys if you're drinking antifreeze. As the percentage of antifreeze in the coolant increases, what happens? Does the heat transfer increase? Does the freeze point decrease up to a point? Does the boiling point decrease? Or does all of the above occur? Actually, the freeze point decreases to a point. When I went to Gatlinburg, Tennessee with these friends of mine back in the 70s to go skiing, which is the only time I ever went snow skiing in my life, and didn't really, I don't know, I realized that after I went down that thing about 70 miles an hour and then crashed at the bottom, I decided I wasn't James Bond. But anyway, this radiator in this Ford that we were driving a 73 Ford LTD that belonged to a friend of mine, and it was 17 below zero the next morning. And so when I went out there and I took the top off of the radiator and looked down in there, the water in the radiator was like a snow cone. Now it didn't freeze. Why does it bust the block when it freezes?
Water expands.
Huh?
Water expands when it freezes.
You know how much?
50%.
9% by volume. It expands.
Versus moisture.
Yeah, and it will. And these things that we call freeze plugs that are inside of the block, they're not there for that. Now sometimes they'll get pushed out when the ice freezes. They won't save the block just because you got those expansion plugs in there is what I like to call them, because they're not really there to save the engine block in case it freezes. What'll happen is it'll usually bust the block anyway, and that's really something that water can expand enough to bust cast iron, but it'll do it. What's another problem with not having enough coolant? Like if you've got clear water in your coolant system, you notice that attacks and rusts everything really bad, and it causes electrolysis and all kinds of chalkiness and aluminum and that kind of thing. It's just really smart to keep your coolant changed. Have you ever changed the coolant in that Kia? Has it ever been changed?
I haven't.
Has it ever been changed?
I haven't, but I don't know if it's ever been done.
If you haven't, you got issues. Okay? So be careful to make sure that you change it. I change my coolant when the manufacturer says it's supposed to be changed. Because a lot of times you think, well, my car's running okay, I don't really care about that. Well, then the next thing you know, you're looking at your radiators like it's got rust bucket. It's terrible. You know, you don't need to go there. It doesn't cost a lot to change your coolant. And if you change it while it's still clean and put fresh coolant in there, then, you know, the coolant can look good and not be so good. You know what I'm saying? It can be getting tired and you won't even know it. And one time I changed the coolant in a vehicle. There was a car that came in that was running too hot. It was a car that I was working on when I was at the Ford dealership. Except we had what we called, you know, Jeep and Eagle, and it was originally bought out by Chrysler and all that. But anyway, and now Chrysler belongs to Fiat. But one way or another, this Eagle Medallion came in there, and it was running too hot, slightly too hot. Not a lot too hot, but just hotter than it should. And when I pulled the radiator cap off, it was full of liquid, but you could tell that the antifreeze had started not to get rusty, but just to change color, and it wasn't the healthy color that it was supposed to be. And all I did to fix that car was drain all of that coolant out and put fresh antifreeze back in it, and it started running at normal temperature. That's all I had to do. And so the point is, it can deteriorate to the point to where it's just not keeping the engine as cool as it should anymore.
How much is some coolant?
The coolant's only about $10 a gallon if you buy it at the parts house over here.
I'll probably do that Thursday then.
Yeah, you can do it. You can. Well, it won't be a problem. Just make sure you do it in the morning and not the afternoon. Adding a chemical to make ethylene glycol bitter to the taste is called what?
Bitter?
Yeah, that sounds like a really good thing. It's not passivization. It's not refractometer. It's not electrolysis. Incidentally, have you ever measured the amount of voltage in your water? You can take your battery terminal, your negative battery terminal, and go from there and dip it into your radiator water, and you'll be surprised sometimes you'll see voltage in the radiator water. Now, what does that mean? Have you ever seen that little science project where you take a lemon and you stick a couple of pins in it and you hook a little weak light bulb between them and it lights up? You ever seen that?
Seen with a potato.
Huh?
Seen with a potato.
A lemon. Did you do it with potato? Or lemons?
I saw something with a potato.
It was a light bulb.
Yeah. But the point is, you can actually, there's, why the unbalance in there, it's acid, right? The pH, below a 7 is acid and above 7 is alkaline. And either way, you'll get electron flow if it's got a path. You see what I'm saying? Well, you know, what the deal is, if you've got a cooling system that's typically, it'll be acid more than anything else. So anyway, the long and the short of it is, if it's too acid, you'll have electrolysis gobbling up your, parts of your block, rusting the metal, turning the aluminum, pitting the aluminum and all that kind of thing. Dexcool is what? Propylene glycol, ethylene glycol, silicate and phosphate free.
C.
It's actually both B and C, believe it or not. Two technicians are discussing and testing coolant for proper pH. Technician A says coolant that has a pH above 7 when new and becomes lower. Says coolant has a pH above 7 when new and becomes lower with use in an engine. Technician B says oat and HOAT coolants, which is organic acid technology and a hybrid organic acid technology. Coolants have a lower pH when new compared to the old green acid technology. Which technician is correct? Both of them. So above 7 would be what? Remember what I said just a second ago? Above 7 is kind of alkali, which is actually going to neutralize acid typically. But the more it gets compromised, the more acid it gets. And that's why old coolant, it's a good idea to get rid of that old coolant and put new coolant in there. Reuse an old coolant is generally not approved by vehicle manufacturers with the exception of who? Mercedes, believe it or not, they let you reuse the coolant. Some of the fluids on Mercedes cars is never supposed to be changed. Like transmission fluid is supposed to be for the life of the car on some of them cars. A voltmeter was used to check the coolant, and a reading of 0.2 volts with the engine off was measured. A reading of 0.8 volts was measured with the engine running and all electrical accessories turned on. Technician A says coolant should be flushed to solve the galvanic activity. Technician B says the ground wires and connections should be inspected and repaired to solve an electrolysis problem. Which technician is correct? B. Dexcool coolant is composed mostly of which chemical? Ethylene glycol. What's Dexcool? You know what that is? That's that orange stuff, right?
I've never actually seen it.
Yep. Which mixture of coolant water solution and below is recommended for general automotive use?
50-50.
50-50, but occasionally you'll see some 30-70 stuff, not very often. All these functions of coolant are of coolant except what? Read them. Rust inhibitor, corrosion inhibitor, cooling system lubricant. Somebody give me an answer.
I'll say D.
That'll be D. All of them are functions of antifreeze. This is painless, isn't it? Nothing much to it. The upper radiator hose collapses when the engine cools. What's the most likely cause? Ding, 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 ding.
Defective radiator hose.
No. You got to understand to begin with how this works. Huh?
Pressure cap.
Yeah, there you go. Listen to him. Why would a defective pressure cap be a problem? Now this is the ones that have the radiator cap on the radiator or kind of like the one that you just worked on, got that kind of radiator cap. Okay, your radiator cap has got this top part, right? And they got a spring. And then they got this piece right here, and it's got a rubber seal on it, right? Well, in the center of that rubber seal, we're going to get a cross section of it. Well, not really. We don't need a cross section. There is a little sort of a thing that looks like this. You know that thing I said it shouldn't be dangling? You remember that? All right, this thing right here has actually got a really weak spring. All right, so when this goes into the radiator and that spring is compressed and you're basically sealed right there. All right, now your radiator neck is actually going to be right here. All right, now you got this pipe sticking out right here, and it's going over here to this jug, right? And that jug is fixed so that it can, this right here can put coolant into that jug, which is, it's a little, the jug is not one of those thick jugs with a pressure cap on it. It's basically going to be a jug that's just like a little flip-up cap. And as the pressure in the radiator rises, it's going to unseat this from the little ridge in the bottom of the radiator, you know, where the radiator cap goes. It unseats that and it pushes coolant in here. Right? Now, as the coolant expands, it's going to push some coolant in there. And as you switch it off and the coolant contracts and gets small again, it's going to drink it back out of here. And what happens when it does that is it opens this little thing here. It pulls it, it's got a very weak spring. You can pull it real easy with your fingers. And the lower pressure in here and the higher pressure here, when this pressure lowers in here, it drinks the coolant back out of there that it shoved over there earlier, and so it go back into the radiator. Now, if for some reason this is either clogged or hung up or stuck shut or something like that, and it has pushed this open and put coolant in there, when it's trying to drink it back, what happens is the upper radiator hose goes flat. Because this thing right here is not working right. That's how the pressure cap can do that. Now, when the trick that I like to do, when I've got a radiator cap like I've taken this spring and stuff off of, I've removed all of this stuff out of here. And when you know, I make sure there's plenty of coolant in here, and I put my red painted cap on here, and as the coolant expands and it goes, you know, out of the radiator, it goes up and it'll go over here. And it can get rid of whatever air it doesn't need. It can drink whatever coolant it does need. Because if you, everybody in here, I'm always hammering on this. If you've got a radiator that's got a radiator cap on it, and I'm not talking about like on the GMC, it'll have, or the, you know, the Taurus or Sable out there. It's got a big, it's got a thick, well-made surge tank that's, I mean, it's got a pressure cap lid on it. If it's not like that, if it's one with a little thin plastic one, and a regular radiator cap on the radiator, you don't just fill this up to where it's full and then put the radiator cap on it and think it's all right, do you? Have you burped cooling system much with your dad? Whenever you do this, you better be watching that thing and wait till that upper radiator hose gets hot and make sure the thermostat's open, because when that thermostat opens, a lot of the time you'll see the coolant in the radiator go slam almost to the bottom of the radiator, because it drinks everything out of the radiator. But if you've got this cap on here and you've got, you know, this here mostly 2/3 full or whatever, or up above the full, it'll actually, if it'll sometimes it'll push air out of here and you'll see it bubbling in there, and then whenever it decides to drink coolant, when the thermostat opens, it'll just suck it right out of here. That way it doesn't puke all over the floor and make a big mess everywhere. That's something I came up with a long time ago. I don't know if anybody else has done that unless I taught them.
Are you talking about the cap that you had, the special cap out there?
Yeah, the red one, yeah. Or the other one. I got several we make. You just take a regular radiator cap and you just, so that you've got the rubber seal that's under here, but all of this hardware down here that seals on the radiator is not there. And that's a real slick way to do it if you don't like it making a mess on the floor. Sometimes even if you're doing it right, you'll just puke water all over the floor. And the tool people make a funnel that hooks onto here that you can, you know, that they can push up and down in there. And that's kind of dumb if you've got one of these. You don't need that, you know. Anyway, you know that, like, this little pipe is always coming off the side of the coolant film neck and all that. That's something. I got a YouTube video on that. Okay, we're doing engine repair test 4, by the way. So let's see what can be done to prevent air from getting trapped in the coolant system when the coolant is replaced. Pour the coolant in the radiator slowly. Use the coolant exchange machine that draws a vacuum on the system. Open the air bleeder valves when adding coolant, either B or C. Now, one of the things that we might see, if you see, and if I had had foresight, I'd have a thermostat here to show you. Sometimes you'll see a thermostat with a little, looks like they drilled a little hole in the plate on the thermostat and it's got a little wiggly thing in there. That's supposed to let the air come out, you know, whenever you're pouring it full of coolant and keep it from trapping so much air in there. It's really a good idea. Then I'll show you that when we get out in the shop. But if you've got bleeder valves, you don't open the bleeder valves with the engine running. What you do with the bleeder valves, and you know, you'll see the bleeder valve. You need to, here, listen to this. You need to make sure to begin with, when you're filling an unusual system, that you know whether or not it has bleeder valves. If it's got bleeder valves, use the darn things. If you open them up and you pour the coolant in until coolant comes out those bleeders, and then you close them back up, and you've probably got rid of most of your air. Some of them you won't ever get rid of the air if you don't. Now, one time we put a motor in a 2003 or 4 Chevrolet Cavalier, I think it was, or something. I can't remember what in the world it was. I wrote about it. But anyway, it said there were bleeders, but there weren't. In the shop manual, there's no bleeders. So what if you think you need bleeders, but you don't? You can take a heater hose loose, and you can fill it up until water comes out of that heater hose port, and then you've pretty much got your block full. You know what I mean? There's a lot of things you can do. But make sure if it's got a bleeder valve, you go find it and open the bleeder valve. Use the bleeder valves. Some foreign cars that have a sort of a wedge shape, you'll have to jack the front of the car up about 30 degrees so that the radiator is higher than the engine before you can get all the water out of it.
What number are we on?
We're on number 12. I just got through there on that one. Heat transfers improve from the coolant to the air when what?
Hey.
Temperature difference is great. That's right. A water pump's a positive displacement type pump. True or false?
True.
What's positive displacement mean?
No.
Is it possible for the water pump to spin without moving water?
No.
Yeah, it is, because all that impeller can just whirl around and water can get past it. A positive displacement pump would be like the one on your jack handle when you're pumping the jack.
Oh, okay.
See, positive displacement pump, oil pump on a car is positive displacement. You know, if it's actually, anytime it moves, something's going somewhere. But on that water, it can actually spin and cavitate. You know, so you got that. Here's a weird thing. Let me hit you with this. It's a Ford pickup, 97 model, 4.2 liter engine. It would sit there in the service bay. We actually replaced the radiator because it had a lot of rust in it. And it would sit there in the service bay and idle all day long at about 200 degrees. But if you got in it and tried to drive away from the shop before you got down there to where you were going to pull out by diesel, it was trying to overheat. But if it sat idling, it would never overheat. Wouldn't have believed this if somebody had told me this, but I saw it happen. And when we pulled the water pump off, the impeller had come off the water pump. It was just laying up in there. I mean, it was rusty because he hadn't, you know, looked after it right. But anyway, that was a crazy thing that I've seen. I would have thought it would have overheated no matter what, you know, but it didn't. Let's see, water pumps, what? A, only work with idle and low speeds and are disengaged at higher speeds. B, are driven by the engine crankshaft or camshaft. C, disengage during freezing weather to prevent radiator failure. D, use engine oil as a lubricant and a coolant.
B.
That's actually B. They're driven by the engine crankshaft or camshaft. This Ford 500 out here that Michelle Gooseby drives, the water pump on that one is on the back end of the front camshaft. It's got its own little small belt. I mean, you don't even have to fool with the belts on the other end of the engine. Now, some water pumps you've got to pull hoses off of them because the lower radiator hose will go to the water pump, and they'll have a heater hose connected to it and all that. But on some of them, it's not that way. Okay. Let me see here. What diagnostic trouble code could be said if the thermostat is defective? And it'll turn on a check engine light too. That's going to be a P0128. A P0128 or a P0125. A P0128 means that the engine is running cooler than it should. And it's typically going to be a thermostat. I mean, just about every time. And a P0125 is a a worse case than a one. What do I mean by that? A more extreme case of it running too cold would be flagged by PO 125 code. So if you see that, you're pretty much just thermostat, end of story. That's not hard. As a matter of fact, sometimes you're troubleshooting in your book, it'll say, if you look, it'll say replace thermostat. That's all it says. Which statement is true about thermostats? A, the temperature marked on the thermostat is the temperature. The temperature marked on the thermostat is the temperature at which a thermostat should be fully open. Thermostats often cause overheating. The temperature marked on the thermostat is the temperature at which a thermostat should start to open. What is it? It's actually the temperature marked on the thermostat is the temperature at which a thermostat should start to open. Now, it's not that thermostats cannot cause overheating, but I will tell you what was really weird. For years and years and years, back in the 70s and the 80s, I would see thermostats sticking and causing overheating problems. I saw a lot of that back in those decades. But when I went to work at the dealership in 1985 over there, I'd done a bunch of work before that, but when I went to work at the Ford dealership, it seemed to me like I almost never saw a thermostat cause an overheating problem. They were always causing them to run too cold. And occasionally, I would have one running too cold, I'd put a thermostat in it, it'd still run too cold, and I'd have to get like 3 thermostats before I got a good one. You know, one time on my, you know how we put the thermostat in the boiling water and watch with the thermometer, see when it opens and all that? I was driving a Jeep Cherokee about several years ago, and it was running, all of a sudden it started running way too cold. I mean, it was like running at 210, which is why I won't mind running at about 210 degrees and has a healthy temperature for an engine to run. If it's running too colder than that, your fuel economy is going to suffer and you're probably going to build some sludge in the engine. If it's running really cold, your heater's not going to work. And you know, if anybody's heater's not working, the first thing you want to look at is you know, coolant getting warm enough. And so I pull that thermostat out of that Jeep and I put it into boiling water and I heated it up and it opened about 196 degrees. And I thought, well, that's weird. Why was it running cool? And I said, heck with this noise, I'm going to put a thermostat in anyway. So when I did that, it ran normal temperature. And then I concluded that the only plausible reason to put the thermostat in the water and heat it up and measure the temperature when it opens is if you believe the thermostat is the cause of the overheating. And we had a car that was overheating one time. And I said, we need to see about the thermostat. We pulled the thermostat, dropped it in the water, we heated it up, and that water was at a high rolling boil, and that thermostat never did open. So we've definitively discovered the thermostat was bad by heating the boiling water. But if you're replacing one that's running too cold, it's sort of silly and a waste of time to test the thermostat because it's pointless. Once you've got it out, what's a thermostat cost anyway? Most of the time, if it's just a thermostat and gaskets, what, $5? You know, that's cheaper than a radiator cap in a lot of cases. Just pop one in there, you know. But realize that you may put one in there that doesn't do any better than the one you pulled out, and you may have to change it a couple of times. Doesn't happen a lot, but I've seen it happen even here.
Really quickly, 11 was A, right?
Yeah, 11 was A. That's right. Okay. Which statement is true about thermostat? Oh, we already done that. It's when the thermostat should start to open is the temperature you got on it. And, you know, years ago they'd have thermostats of various different temperatures, and some people feel like too cold is better than, you know. There's another thing I like to say while I'm thinking about it, because if I don't, I'll forget it, and I'd like for you guys to know it. The reaction surface that the impeller on the water pump operates next to is either built onto the pump or it's actually into the thing the pump is spinning next to. In other words, it's either on the pump itself or the impeller's turned the other way, like the ones you see over there. And in some cases, and I actually bought a water pump one time and put it on a car and it ran too hot. Not too hot, but hotter than it should. And the old man that owned it didn't like it. So I pulled that water pump back off and it determined that the impeller, the reaction surface, was on the pump itself and the impeller had to be a certain distance from that. And it was too far. Whenever they rebuilt the water pump, they didn't push the impeller far enough on there. There was too much space between the impeller and the reaction surface. And because it's not a positive displacement pump, it was like, you know, a cavitated pump, and it ran too warm. So when I put a thermostat on there, I measured it with a feeler gauge. It was like 70 thousandths, and it was like 20 thousandths on the next pump I put on there, and it ran real cool. So remember that. Pay attention to the impeller. you can have impellers on water pumps that are melted away. I got one over there we pulled off of a Taurus, and it wasn't overheating, but she had no heat. Got me? All right, so if somebody says I've got no heat and you've discovered the blend door is okay, you pull both heater hoses off, loop them out with a clear hose, which you can buy from Ace Hardware, crank it up. If there's no water going through that heater hose, you need to be going to look for a water pump problem. Be surprised. The impeller is either spinning on the shaft, if it's one of those plastic ones with the aluminum thing on the hub, or if it's a steel one, it's melted away by rust. And like I say, that's what we found on that one Taurus, is she had a lot of rust in her cooling system. Let me see, the customer complains that the heater works sometimes, but sometimes only cold air comes out while driving. Technician A says the water pump's defective. Technician B says the cooling system could be low on coolant. B, if it works sometimes, you probably don't have water pump issues. But if it's low on coolant, and that's one of the reasons that when you're filling it up with coolant, it's a good idea to turn the heater on high. If the heater was working before you started working on it, and you turn it on high, and you fill it up, if that heater's warm, that's another indicator that you've got plenty of coolant in it. You understand what I'm saying? If you don't have heat, you know, then you'd be thinking you might be low. But don't do like the guy that I know that popped a radiator in his own vehicle, didn't pay any attention to me when I told him he needed to wait until the thermostat open, drove off on it. He was one of my students. Down there in the parking lot, it tried to overheat, and he took the radiator cap off when it was hot and got burns all over his stomach. Like a dummy. If he'd have filled it up and paid attention to what I was telling him instead of going off half-cocked, you know, when it happened, he was all bandaged up for a while. Did it to himself. A customer complains, never mind. The normal operating coolant temperature of an engine equipped with a 195-degree thermostat is what?
D.
195 to 215, that's right. That's where I like mine to run. Technician A says cooling fans are designed to draw air through the radiator to aid in the heat transfer process. Technician B says drawing the heat from the coolant transfers the heat to the outside air through the radiator. Who's right about that? Both those guys are right. However, here's something else you need to recognize. You might say, and this is an overheating thing that I'm going to tell you about. We got, I've seen them overheat, and you look and look and look, and you say, I don't really see anything wrong. But then when you take the condenser, the AC condenser, and you move the radiator away from the AC condenser so you can look down in between them, you might find out that the doggone radiator is clogged up with weeds and dog fennels and all kind of crud that went right through the condenser and didn't even slow down and stopped when it hit the radiator. And just because you look at that AC condenser and you don't see any weeds or anything doesn't mean there's not any on the inside. And I have taken radiators out of a vehicle and just washed it with a pressure washer kind of gently to get the dirt and crud out that was stopping it up so it didn't have airflow. Put it back in and seen them run cool. Particularly on farmer's truck, you know, because they drive out in the field a lot. You'll see them that's overheating, and there's no use in throwing a bunch of parts at it before you make sure everything else like it's supposed to be. That's the point. Here's something else. Another overheating concern can be caused. Let's say that you got one that's overheating and nobody really knows why, but is overheating when you're driving but not when you're stopped. Right? Usually if you got a bad cooling fan, it'll overheat when you're in traffic or sitting at the red light, but it won't overheat when you're in the wind. Well, this one overheats when you're driving around, but it doesn't overheat whenever you're parked. And so you walk up there and you look in there and you see that somebody has put a new fan on it, and it's one of those fans that came with just the wires dangling, and you're supposed to hook the pigtail in and then hook the stupid fan up backwards so that it's blowing instead of pulling. All right, so how do you determine that that's the problem? You take a piece of paper and put it down there, and if it blows it forward when it's just parked in the service bay, you know the fan's wired up backwards, and then you can fix it, right? But there's another thing that happens sometimes. We bought a brand new blower motor from down here at the parts store because the blower motor was not working right. And when we put that thing in, it made a lot of noise, but it wouldn't move in the air. You remember that one? Were you here then? And we got it up here on the bench, and when we hooked it up, it was built wrong so that it was running backwards. And when they put the magnets in upside down or something when they built it. And I actually saw that on a vehicle, I mean so think about this, if somebody built a radiator cooling fan that way, you know, just factor in everything. That's the point.